Let's take a look at section 4.2, and in this section we're still talking regression lines, but we're going to get a little bit more specific about how strong an association is. So the name of the section is Measuring Strength of Association with Correlation. So the correlation coefficient is a specific number that we're going to use to describe how strong an association is. And we're going to use StatCrunch to calculate this number for us, so we're not going to have to do anything to calculate it by hand, but we have to know how to interpret it when we see it. So a number that measures the strength of a linear relationship, so this only applies to relationships that are linear, which is all we're going to work with, but keep in mind that if you ever see something that's not linear, this wouldn't work to describe it. We use the little symbol r, lowercase r, like that, to denote the correlation coefficient. R always takes on values between -1 and +1. I should say -1 and +1 inclusive. So it could be -1, it could be +1. Usually it's somewhere between the two, but it could be. An R value close to -1 or +1 indicates a strong linear association. An R value that's closer to 0 indicates a weak linear association. So let's look at a picture here, just kind of giving us some of the different cases. So the first case, we've got a perfect positive correlation. So it's a positive trend. Everything lines up perfectly on that line. In this case, R would equal 1. Now, in the real world, that's pretty unlikely to occur. Most things, there's going to be some variation, but that would be a perfect scenario. In the next picture, we've still got a positive R value because it's a positive trend. So whether R is positive or negative indicates whether the trend is positive or negative, just like the slope of a line would. It's similar in concept to that. So we've still got a positive value. So R is still a positive number. I'm sorry, we still got a positive trend. So R is still a positive number, but it's not perfect. So R would be, in this case, and I'm guessing here because I don't know what this is, R would be somewhere around 0.75. So it's still up there. It's still fairly close to 1, and it's positive. So you've got that positive trend, but it's not perfect. So it's not 1. It's somewhere a little bit lower than that. A weak positive correlation, so in this case, it looks like there might still be a little bit of an upward trend, but it's definitely weaker than it was in the previous picture. So this might be somewhere around R equals I'm guesstimating maybe around 0.30, 0.25, somewhere in there. So if there is no correlation, then your R value would be 0. So if there's no apparent correlation, the points are just scattered all over the place, R is 0. Then we can go backwards and we can have negative trends. So in the next picture, we've got a weak negative correlation. So this would have a negative R value, and it might be similar to the one above it, I don't know, somewhere around 0.3. I'm guesstimating because I don't have the numbers from StatCrunch, but I know it would be a negative number, and it would be small, close to 0. In the next picture, we've got a stronger negative correlation. So this would be maybe somewhere around R equals negative 0.75, so it's analogous to this one we had up here, but in the negative direction. And then in the last picture, we've got a perfect negative correlation, so this would be analogous to the first picture, but in the negative direction, so we'd say R equals -1 in that picture. Again, pretty unlikely to get that in the real world, but that just gives you an idea of what the scale is. All right, so let's look at this example. Correlation coefficients of -1 or +1. So exactly -1 or +1 indicate a perfect positive or negative association. In that case, the data points lie exactly on a line. Consider the following scatter plots with the correlation coefficient for each plot given. So these would have come from StatCrunch. I don't know exactly what this data represents, but I want you to see above it what the R values are. It's kind of hard to see, so you have to zoom in a little bit, but the R values are shown right above each one. So the first one is a pretty weak correlation. We could say it's positive, but it's a pretty weak association. The R value is only 0.1. The next picture, we've got a little bit stronger association, still positive trend, and the R value there is about 0.33. In the last picture, we've got a much stronger association where the R value is about 0.89. There's no definitive, if R is above this, it's strong. If R is below this number, it's weak. it's very subjective, but more often what we're going to be doing is comparing, where we're going to look at one picture compared to another and think about which one would have a stronger relationship or stronger association. So it says, note that as R increases, so as the R value itself increases, there is less vertical variation. In other words, we have a stronger trend. Remember in the last section, we said little or less vertical variation, like in this picture, the points are tighter around that line. That means a stronger association. So a bigger R value indicates less vertical variation or a stronger association. How do we get the R value using StatCrunch? So you're going to put your data into two columns and label them separately. So you'll have one in your, like an X column, your independent variable, and one in your Y column or your dependent variable. And then you're going to go to the Stat menu, choose Regression, Simple Linear, choose the X value and choose the Y value, like indicate what they are, and then click Compute. So let's take a look at this example. And I realize we don't have StatCrunch in front of us, but that's okay. I just want to show you when you follow these steps above, I want you to see what the output is going to look like in StatCrunch. So let's take a look. The table below gives the number of miles driven on a recent trip for 8 rented cars and the amount of gas in gallons used for each trip. Compute and interpret the R value. Okay, so our miles driven is going to be our independent variable, so I'm going to call that X. Our fuel consumption is going to be our dependent variable, so I'm going to call that Y. And what we're looking at, so it's a small sample here. We've only taken 8 vehicles and we've looked at this data. So in StatCrunch, I've put the miles in one column, I put the fuel consumption in the other column, and then I followed the steps in the box there, and then here's what it gives me. So it tells me that the dependent variable was fuel consumption, and that's because I chose that. The independent variable would be the miles. And so this is the way it writes the equation. It's a little bit strange looking because they don't use X and Y. They use whatever you call the variables at the top of the column when you put it into StatCrunch. When you put the data in and you label the columns, it uses those names that you've chosen in the actual equation itself. But pay attention to the structure here. So fuel consumption equals this 1.347 number plus 0.0294 times the miles. And so this is essentially in the format of the equation of a line. If you remember from algebra, the slope-intercept form of a line, you would write it this way. You probably wrote mx plus b instead of b plus mx, but it's in that format. So miles, remember, is your independent variable. That's like your x variable. Fuel consumption here is your dependent variable. That's your y value. Sample size, it tells you is 8, and it gives you the R value. Now, StatCrunch uses a capital R. When we write it, we usually use a lowercase r, but your R value is this number right here. So it gives me a lot of decimals here, and we could round this and just say that the R is approximately 0.91 if we wanted to round it. But without even looking at a picture, what would you say about that correlation? Would you say that's a strong correlation or a weak correlation? Well, 0.91 is pretty close to 1, so that's going to be a pretty strong correlation. The rest of this information we're not going to use at this time, so don't worry about it. So based on the results computed by StatCrunch, what is the R value? So let me go to the next page. So the R value, let me go back. So I wrote it there. R is about 0.91 if we round it. And then it says and what they're looking for here is how to describe that R value. So since R is close to 1, we would say that there is a strong linear association between mileage and fuel consumption. And again, I don't want to give you a really hard and fast rule, use this every time, but generally if R is greater than about 0.75, even 0.7 perhaps, that's going to be a strong association. And so 0.91 was a pretty strong association. Important notes about the correlation coefficient. So if you change the order of the variables, so in other words, if you swap the x and the y, it does not change r, which is an interesting characteristic. Adding a constant or multiplying by a positive constant to your values does not affect r. R is unitless, so it's not measured in any kind of unit. R is only useful to measure a linear trend. And like we said, that's all we're going to look at are linear trends. And it says always graph the data first to make sure that we're looking at a linear association. So the next picture, it says match the correlation coefficient to the correct graph. So below, we've got 4 correlation coefficients, and then we've got 4 pictures, and they want you to match them. So use a little bit of process of elimination here, but sort of think about what the trends are for each of these pictures. So I would say in these first 2 pictures, we've got a positive association. Picture B, I would say, is a pretty strong positive association. Picture A, I'd say, is still positive because there's sort of this upwards trend, but it's definitely weaker. So we can say this is a weak positive association. And then picture C, so I think picture C, it's still positive. I think C actually falls kind of in between the two. So we could even say that this is a moderate. That's a fair word. We could say moderate positive association because it's going to fall somewhere between picture A and B. And then what do you think about picture D? Hopefully you see that it's got a negative trend. How strong is it? It's hard to say without a number. I would say you could say weak to moderate. It's up to you, weak to moderate. But now that we've kind of identified a general characteristic for each one, a general description for each one, let's match the R values to each picture. So the highest R value is this 0.885 number. That's closest to 1. And so that's going to go with picture B. The 0.724 would be the next highest R value. And so that would be the next strongest trend, which I would say is picture C. And that means the picture picture A rather, is the weakest positive trend. That must go with the R value of 0.119. So that's picture A. And then, of course, the only one that's negative was picture D. So that has to go with negative 0.341. And there we go. So the next question, it says, suppose a new data set has been added to the example 4.22, which I think was on the previous page. Let me back up. So yeah, our data with our miles driven and our fuel consumption. Oops, let's see. Let me go back to that example. So it says, suppose a new data set has been added to the table in 4.222 with the new scatter plots shown below. All right, so we're looking again at miles driven for the independent variable versus fuel consumption for the dependent variable. All right, so describe and interpret the association. So it asks us to describe and interpret the association. So we could say it is positive because it's going up. How strong is it? I don't have the R value in front of me, although I think we had it earlier, but we won't worry about the R value. We'll just say, since there's not a lot of data points on here, we can say we have a positive. Actually, let's say moderate positive, just to be on the safe side here. Let's say moderate positive, and it is linear, so we'll throw that word in there, linear trend, or let's say linear association. If we were to describe this in words, we could say that as miles driven increases, the fuel consumption tends to increase. And that's what I mean by don't say it definitely increases, just say it tends to increase, because there's always some exceptions to these. The points have a little bit of scatter to them. So you always want to throw that word tends to in there if you can, or something similar. What do you think happened with the one point that does not follow the trend? Does it seem accurate? So they're talking about this point over here. So does it seem reasonable that we drove 800 miles on two gallons of gas? And so how could we maybe account for this? It could be that it was a mistake. Could be somebody typed the data in wrong. It could also, somebody point out one time, it could be an electric vehicle. So that's a possibility as well. But you can see that it doesn't follow the rest of the trend. So we need to address that in some way and give some explanation for it as the researcher. Part C. There's one more example, and I apologize because I think it may have gotten cut off in the printed notes, but it's a pretty good question, so I wanted you to take a look. So I'm looking at this graph down here at the bottom, and I'm comparing two graphs, and I apologize that this is not the best picture, but let me just explain what you're looking at. So we're looking at the average miles per gallon of fuel consumption for passenger cars. So in the first graph, we're comparing the horsepower of the car to the fuel consumption this way. In the second graph, we're comparing the cab space, I think it was in cubic meters or something along those lines, versus the fuel consumption this way. So part B of the question, it says, what is the approximate average miles per gallon for a car with a horsepower of 150? So they're just trying to get you to kind of get used to reading what you're looking at. So if I look at the first graph, horsepower is here, and if we kind of trace it up, and I'm just estimating it, but the average, if I'm looking at the model, looks to be around maybe 30. So I'm going to say this is about 30 miles per gallon. Okay? Are these associations positive or negative, or is there no trend? And so hopefully you see they're both going downwards, and so in both cases we will have a negative trend. And then D says, which of these has a stronger relationship with average miles per gallon, the horsepower or the cab space? So here you're looking for the strength of the relationship. Which one seems like it's got a stronger relationship between the two? And hopefully you see that there's more vertical variation this way in the cab space, which indicates that's a weaker relationship. So we would say that the horsepower is stronger, and the reason is because there is less vertical variation. If we were asked to say which one gives a better prediction for miles per gallon, the car's horsepower or the cab space, we would certainly say horsepower, because that had a much stronger relationship between that measurement and the miles per gallon versus the cab space and the miles per gallon.